All right, so we didn't finish up on a few things yesterday, so we're going to go ahead and look at a few of these graphs, make sure we're understanding what's going on with these polynomial functions and their end behavior. So we were on number 16. Thank you. I'm going to go ahead and put that into the graphing calculator. All right, I'm going to put it in descending order, please. -3. X to the 11th. Be careful when you're typing these in. You have to arrow out of your exponent position. And then I'm putting it in descending order. You need to know how to write it, of course, in descending order when necessary. It's not necessary to get this job done, and I just have this slow computer that likes to tell me to shut off stuff that I'm trying to use. But I must ignore it as long as I possibly can. Okay, I'm going to hit Zoom 6. Okay, now this was the 11th power. I wasn't sure if I was going to be able to see everything. And I can tell that I am. How do I know that I am? Probably because I have an up on the left and a down on the right. Looks like I'm seeing the entire graph. The end behavior is showing. I was expecting up on the left because it had a negative leading coefficient and it was odd. Okay. So I believe I've got everything. I'm going to zoom in so I can see kind of what's going on in the middle. After you hit zoom in, you have to hit enter for it to zoom in. And I'm just waiting to see that didn't show me what I wanted to see. Oh, well. So sometimes zoom in doesn't work. So I'll zoom back out. How many turns do we see? 1, 2, and then it looks like it's coming back down a little bit. Maybe, or is that flat? 1, 2, then it's turning 3, and then 4. 4 turning points. Okay, so it kind of looked like this. Oh, I have to have a pen to draw, don't I? All right. So this was, it said to determine the end behavior and the number of turning points. This one had 4 turning points. Okay, it sort of looked like this. Kind of not showing, I guess right there was another one. Oh. I made it kind of a weird Z thing. And the end behavior was up on the left, so f of x was approaching infinity as x was approaching negative infinity. And f of x was pointing down on the right, so that would be f of x is approaching negative infinity as x approaches positive infinity. Okay, now I'm going to look at the next one. I'll be back there shortly if you still needed something. I'm going to put it in descending order, -2 x to the 8th. Arrow out of that exponent plus x to the 4th plus 1. Oops. See what happens when you don't. I don't want to have to start all over, but you got to arrow out on these new operating systems to get out of the exponent. Okay, if that happens to you, you can back up and hit delete until you get where you want to go. All right, Zoom 6. Well, it's already on Zoom 6, but I always just like to square up my window, make sure everybody's seeing the same thing. Up, down, down. Was that an even? And it was open, and the leading coefficient was -2. So I expected it to be down, down. And how many turning points? 1, 2, 3. Okay, should be 3. Okay, so this one had 3 turning points. The end behavior was down, down, so f of x is pointing towards negative infinity as x approaches negative infinity. and f of x, the graph, is approaching negative infinity as x approaches positive infinity. Okay? Sure. And this one looked like that, right? Okay, can we, oh, and I don't know why, I guess I just did them all and that was a repeat. All right, now, without the calculator, let's think about state the degree and the leading coefficient of each polynomial. Sketch the end behavior based on the degree and the leading coefficient, whether it's positive or negative. If it's not a polynomial in one variable, explain why. All right, this is a cubic. It has a degree of 3. It has a leading coefficient. Let's do LC for that, so we could abbreviate, of 1. Okay, the end behavior then I would expect, since it has a positive leading and it's odd, would be to be down and then up. And that's what it means by end behavior, to show what you expect to happen on the left and the right. That's all we had to do, right? Oh, well, I'll say we'll describe the end behavior. F of x is pointing towards negative infinity on the left, which would be as x approaches negative infinity. And the graph f of x is approaching infinity as x approaches infinity. Okay, 19 is degree 2. It has a leading coefficient of 7, which is positive. Therefore, I expect the end behavior up, where f of x is approaching infinity on the left as x approaches negative infinity. And f of x is also approaching infinity on the right-hand side as x approaches infinity. What's the highest power on 20? It is a degree 4. The leading coefficient is negative 3, so I expect the end behavior to be down, down, which would mean f of x is approaching negative infinity as x approaches negative infinity. And f of x approaches negative and infinity, that's the graph, as x approaches positive infinity on the right. Yes, Hannah? If it's asking for the degree, yes. So the degree is a number, okay? So you are right that it's a quadratic, though. This would be a quartic. But it didn't ask for the name, it just asked for the degree. Okay? I don't know, I mean, I'd probably know what you meant because you knew it was 2, okay? But if it is actually, like, say it was multiple choice, it's not going to say that, okay? All right, 21 is a continuation of that. The highest power is 5, so this is degree 5. And that would be a quintic if you named it. This has a LC, leading coefficient of 9. It's an odd, so if it's the leading coefficient that's positive on an odd function, should be end behavior down on the left, up on the right. So f of x should point towards negative infinity as x approaches negative infinity. And it should point up on the right to infinity as x approaches infinity. And finally, number 22 is degree 7. And a LC, leading coefficient of negative 7. That's an odd degree, so it should be up on the left, down on the right. So f of x approaches infinity as x approaches negative infinity. And f of x is pointing down to negative infinity as x approaches positive infinity. Okay. All right, the assignment is printed up for you on the worksheet. If you haven't started it, you need to do it over the weekend. We are now going to go to 3, worksheet 3A. And we will be doing 3A and B. And the book page for that is on the last page of the book assignment packet I gave you today. Now, this isn't really new material, most of this. Matter of fact, a lot of this is just review. But it's about adding, subtracting, and multiplying polynomials. When adding polynomials, you can align things vertically. You're trying to combine the coefficients of the like terms when you add or subtract. You can use vertical or a horizontal format. If you're adding vertically, you add the lead coefficients. 3x cubed plus 1x cubed would be 4x cubed. Positive 2x squared plus a negative 10x squared would be a negative 8x squared. There is no x term in the second group, so that's why there's a little gap, and then you bring down a minus x. And then negative 7 plus 8 would be plus 1. If you're doing a similar problem horizontally, if it's addition, you just drop the parentheses. You look for like terms, and you combine them. There are no like terms to the 9x cubed. There's no other x cubes. There are no other x squared, so you bring down the 5x squared and keep going in descending order. I look for the next power of x, which would be x to the first. I have a negative 2x and a positive 12x, which gives me 10x. And then I have 2 constants. I have a positive 1 and a minus 4, and that would give me minus 3. When you're subtracting, that's when we get some difficulties. What I would suggest, if you're subtracting, you always really need to rewrite the problem, okay? Because you're subtracting everything in the parentheses, you can change this to an addition problem by rewriting it. You don't change the top. It'd be 8x cubed minus 3x squared minus 2x plus 9. But the second thing to do is to distribute that minus sign throughout the entire parentheses, giving us negative 2x cubed minus 6x squared plus x minus 1. Then you can combine vertically. 8x cubed minus 2x cubed would be 6x cubed. Negative 3x squared minus 6x squared would be minus 9x squared. Negative 2x plus 1x would be minus 1x or minus x. And 9 minus 1, of course, is plus 8. All right, so that's all there is to it. Now, if you're doing horizontally, you would rewrite dropping the first parentheses. To drop the second parentheses, you need to distribute the minus sign to each term. So negative minus 3x squared minus x plus 4. Then you could horizontally look for like terms. 2x squared minus 3x squared would be negative 1x squared. I got a 3x minus the x. That'd be plus 2x and then plus 4. Okay. Anybody still need this page? All right, I know you're on the same page of paper, but my screen. Wait a second. Do you have a question? No? Here? No, 8x cubed minus 2x cubed. 8 minus 2 is positive 6. Is that where you're looking? Okay. All good? All right, to multiply 2 polynomials, each term of the first must be multiplied by each term of the second. So that's why I mentioned to you that I wasn't real crazy about the FOIL method, because I'd rather you knew to double distribute, okay? Because now we could do triple or quadruple if we needed to. Okay, so if we're going to multiply the polynomials, we have to multiply the entire thing by x. So I'm going to do that first. That would give me negative 8x cubed plus 2x squared plus 4x. Next, I'm going to multiply with a different color times negative 3 times everything, which give me a positive 3x squared, negative 6x, and negative 12. Okay, so multiplying them, we just did it. And then we need to look and combine on any like terms. So I see there are no other x cubes, so I bring down negative x cubed. I've got a positive 2x squared plus 3x squared, that's plus 5x squared. I have a positive 4x minus 6x minus 2x, and then minus 12. Better? Okay, when we do number 6, we're going to multiply through by x over all 3 terms. So you can show it like this, much like I did arrows when we distributed. That's going to give me 3x to the third minus 2x squared minus 4x. Did you find it? Okay. Then I got to multiply through by negative 3. So I'm just showing that in a different color. That would be negative 9x squared plus 6x plus 12. I look for any like terms. There are no other x cubes, so I bring down 3x cubed. I have a negative 2x squared minus 9x squared would be a minus 11x squared. I have a negative 4x plus 6x, that'd be positive 2x, and then a plus 12. Okay. Oh dear. Number 7. I have a suggestion on order to do things. I don't want to, I could either multiply the first two, or I could multiply the second two, but I can't do them all at once. Okay? So I'm thinking I'm going to do the second two. I'm going to drop the x minus 1 down. Okay? And then I'm going to go ahead and multiply out x times, I'd have x squared plus 3x. Are you okay? I'm sorry. Oh dear. You got to take your time and go one at a time. Sorry. And just write them down as you go. Which one are you on, hon? Do you think maybe some color would help? Okay, you're right. All right. All right, so let's go through this one. I'm going to multiply the second pair. I'm going to basically FOIL it out, which I don't like to say. Distribute the x over the x and 3 gives x squared. Sorry, I wanted to change color now. Plus 3x. And now I'm going to multiply by 4, which would give me positive 4x plus 12. Okay, before I continue the problem, I'm going to simplify. And you may have done that already in your head, and that would save you a step. X squared plus 7x plus 12. I want to have that simplified to that. Okay, now I'm going to go ahead and do a double distribution of multiplying through by x over the 3 terms in the second parentheses. That gives me x cubed plus 7x squared plus 12x. Next, I'm going to multiply through by negative 1 to every term, which would be minus x squared minus 7x minus 12. Are you with me now? All right, now, combining like terms, I've got an x cubed. I have a 7x squared minus a 1x squared, so I'll have 6x squared. I got a 12x minus 7x, which would be positive 5x, and then I have a minus 12 constant. All right, so could you guys tell me what you think we should do next first on number 8? Yep, do this thing. I have taught you how to shortcut square a binomial. The shortcut is x times x squared. X times -5 doubled, negative 10x. And then -5 times -5, positive 25. That's the perfect squared trinomial. Now I'm going to do my double distribution. I multiply through by x. That will give me x cubed minus 10x squared plus 25x. Then I'll distribute through with 2. I'll have positive 2x squared minus 20x plus 50. I don't have any other cube terms, so it's x cubed first. I got a negative 10x squared plus 2x, b minus 8x squared. I've got a 25x minus 20x, so that's going to be plus 5x. I have nothing else but a 50, plus 50. Now, did you notice that when you multiply 3 things, if you will, of 3 binomials, you end up with 4 terms in the end? 4 terms. So now I'm going to show you these patterns. I'm not asking you to memorize. These are patterns that you could memorize. We definitely know these, and those you should know. All right. We have done this. So all this is knowing that if you multiply conjugates, you get x squared minus b squared. And this is an example with numbers. If you square a binomial, this is the pattern I was just talking about a quick squaring of a binomial. A times a squared, a times b doubled, 2ab. B times b is b squared. This set, you should know the difference, and you should know how to do it with numbers, of course. Now, these are all, never mind, I wasn't where I was at. So you should know these, and this is just examples with numbers. So if I square this, we should be able to go really quick because I've already taught you this. X times x squared, x times 2 is 2x, doubled would be 4x, and then 2 times 2 is 4. Okay, 3x times 3x, 9x squared. 3x times -4 is -12x, doubled is -24x, and last would be plus 16. And then these are conjugates, so it would be x squared minus 49, because the middle term would drop out. The better you know these, the better you are probably at factoring as well. This part is what I was really referring to, that if you would like to memorize this pattern, it could be helpful. But I am not probably going to do the binomial expansion theorem papers that are in this packet unless I get to them at the very end of the unit, depending on time when we're getting ready for finals. Okay, so it's not critical to this course. We were going to touch on it, but you will do it in pre-calculus. So right now, I expect you to be able to go as high as power 4 by hand. Okay, so you will have up to a 3 or a 4 on a quiz. A 3, what do you think we might do? So I'm going to show you how to do it based on what we were doing a few minutes ago. If I want to cube a binomial, instead of memorizing this pattern, which you, again, could do, that's the first in the binomial expansion theorem, I would say let's just break it up into x plus 3 times x plus 3 quantities squared. You get what I'm doing here? So then what I do is go ahead and do the quick way of foiling out a binomial. Okay, which is a binomial times the binomial, x times x, x squared, x times 3 doubled, plus 6x, plus 9. Okay, and then continue on by just double distributing. So multiply through by x, get x cubed plus 6x squared plus 9x, and then multiply through by 3. That'd be plus 3x squared plus 18x plus 27. And then all I would ask, of course, is for you to combine like terms, which would give you x cubed plus 9x squared plus 27x plus 27. Okay, so I'll do the same for this one. 2x minus 5 times 2x minus 5 quantity squared. Okay, so I'm just going to rewrite the 2x minus 5, the first one, and do the quick foiling of this, which would be 2x times 2x, 4x squared. 2x times negative 5 is negative 10x. Doubled would be negative 20x. And last, plus 25. Okay, and then I'm going to distribute 2x over all three terms, which would be 8x cubed minus 40x squared minus, oh, that'd be plus, excuse me, 50x. And then multiplying 3 by negative 5 would give me minus 20x squared plus 100x minus 125. Now, I know I'm kind of going fast because I do a lot of my own mental math. So if it was a little fast, obviously you can do it a little bit slower if you need your calculator some of the time, I guess. Okay, so I got 8x cubed. I have to combine negative 40x squared and negative 20, so that's minus 60x squared. And then I've got 50x, 100x, so I have 150x, and then at the end, minus 125. Does anybody still need this then? I can hold off. Okay. Part 5, this is just from an application of using two functions and possibly adding or subtracting them. So it says from 1985 to 1995, the gross farm income and farm expenses, E, in billions of dollars in the United States can be modeled by those functions in billions of dollars, where T is the number of years since 1985. Write a model for the net. What would the net be? It's some combination of these two things, right? But one of them is income and one of them is expenses. All right, so we need to subtract the expenses from the income. So we've got negative 0.46 t squared plus 7.88 t plus 159. And from that, I need to subtract the E function, or E, the expenses. So that's going to be negative 0.174 t squared minus 2.54 t minus 131. Okay, everybody understand why I changed all the signs? I went ahead and did it instead of writing it and then doing it. Does that make sense? I'd have to put a parenthesis around it. So I just lined them up, and I'm ready to go now by addition. So I'm just going to combine. Oh, goodness. I'm going to go backwards because that's the only way I can add these without a calculator. So, see, 4 and 6 is 10. So I'm going to carry a 1. That's going to be 12. Carry a 1. So it's going to be 0.42, negative 0.42 t squared. And you guys help me out. Make sure I do this right. 5 plus 5.34 t, and then last plus 28. Okay, so that would be your net N. All right. The next one says you're trying to raise for your trip to Spain, and you decide raise money for your trip to Spain. That would help. And you decide to sell cookies. No, you're going to raise into the sky and fly there. Okay. The revenue. What's revenue? How do you make it? All right. So revenue function is what you're selling it for. All right. You go out there and you say, I want how much? If the revenue function R of X is 250. What? Oh, I just said the answer. Oh, my Lord. 2.5x. What's that mean in money, honey? That would be 250. I just told you. All right. So that number in front of x is what you're selling the dang thing for. All right. Moving on. The cost. Uh-oh. It costs you money to make those cookies. So your mother, when she sent them to the bake sale, and the bake sale got all the money, Mom paid for all the cookie dough and stuff. All right? You get my point? So they make the money off. So it's not the same. If you're selling for yourself, you got to consider your expenses. So if your cost equation is x plus 32, what would we do to get a profit function p of x? You'd need to take your revenue minus your cost, right? All right, so we have to take our revenue of 2.5x and subtract from that the x plus 32. Now, I have to put that in parentheses for a good reason. Because I need to subtract, I have to distribute that minus sign. So I'm not just subtracting x, I'm also subtracting 32. Now I would simplify this, and then I can write my profit function p of x. 2.5x minus x would be 1.5x, and then minus 32. Now you've got a profit function. Now, you want to know what your profit for selling 381 cookies. That is a lot of cookies. You need to plug in 381. Now, do you think you might need to do this if you have a business? Oh, yes, you do. So, pizza, they got to factor in what it costs them to pay employees, to pay for the electric bill, to rent the space, to make the pizza dough, to make the sauces and the toppings and everything. And it's complicated, way more complicated than you might think, how they have to come up with a price that's going to make them profitable. If they don't, they're not going to make any money, and then they're just going to have to close. And that happens to a lot of restaurants. One of the worst ventures, or most likely to close within 2 years, I think it's about 2 years, don't quote me, it's a restaurant, right? Okay. Anyway, what do we got while I did all that babbling? $530.50. We made 381 cookies. How many dozen cookies is that? Over 30 dozen. Dozen cookies. Oh my goodness. Your oven was on for a while. Might have to get a bigger oven. All right, more than one oven, yeah. Okay, quick review, please, on exponents. All right. We've already gone over exponent rules this year, but we need to revisit them. If you have power rule, you apply the power to everything inside the parentheses. So it'd be 4 to the 4th, x to the negative 8, y to the 20th. And then you have to make all your exponents positive and evaluate any numbers. 4 to the 4th is 256. Y to the 20th would stay there with the 256. And what would we do with x to the 8th? It's not x to the 8th yet. To get it to be x to the 8th, what do we do? Put it on the bottom. Okay. The next one, I see a negative outside of the parentheses. So instead of applying it to everything, I'm going to just flip it first. Remember that a negative exponent, n to the negative 1 equals 1 over n. That's the property we used over here. We're going to go ahead and make this into a fraction. And on the bottom, you'll have negative 2, a to the 3rd, b to the, just b, c to the, is that a 5 or a 6? 6, and then to the 2nd power, because we did reciprocal, we got to change that negative exponent to a positive exponent. Now I apply that squaring of the bottom to everything inside there. Negative 2 squared would be 4. I'd have a to the 6th, b to the 2nd, c to the 12th. And that's done. Okay. I have some k's. I said k. Is the k on the bottom k to the 6th? Alrighty, so where do we have more k's? All right, and that a to the negative 3 can't stay there because he's got to become positive, so he gets to go to the basement. So we put a to the 3rd on the bottom. And then you just told me you have more k's on the bottom. And that B doesn't have any reason to move, so he stays down there. Going to hang out with a to the third. And then, uh-oh, how many k's will we have left if we reduce it down? 1. Wait. Okay, the rule, guys, is to subtract the exponents. Okay, so that would be a -3, but you're going to leave it down there and it'd be k to the positive third. But wait a minute, what happened up here? All right, so you left number 1. Your mom's still upstairs. Okay, just kidding. Okay, so, you got to have somebody up there, right, holding the fort. All right. You can't just all of a sudden eliminate the cup. All right, apply that power in there. W to the, what's that? -18? You got to multiply. And k to the third. And then, uh-oh, he's got to go downstairs. So somebody has to stay upstairs, and what's it going to be? 1. All right, number 1. K to the third on the bottom, W to the 18th on the bottom. So I'm thinking about Thanksgiving and kitchens and everything else. Oh my goodness. Let's flip this guy over. And why am I flipping it over? Yeah, I want that 4 to be positive. Okay. Now, you could do some work inside here. So why don't we do that and then apply? I don't care what order. I've done this problem with you before. I know that I have to take 3 to the 4th, though. And that's 81. If you want to go ahead and apply the power to them all, you can. Or what do you want to do? All right, I'll just do it. I'll do it as if we applied the power to everything. It's not the only way to get it done. The problem is that we got to figure out the final answer. It's going to be 81m to the what? 4 minus -8 would be? No. 4 minus 12, and then 12 minus 8 would be p to the 4th. You have no one downstairs anymore. Everybody came upstairs to eat. So I'm thinking of Thanksgiving. It's next week. All right. So have a nice weekend. Oops, next time this gets played to somebody in another year, it might not be Friday, but I'm done. Timer time. Over.